Hello friends, so here is another question on temperature measurement and temperature scale. It is given to calculate the temperature at which the readings in Fahrenheit and Kelvin scales, they will be the same. The value will be the same. So again we will be using the interconversion formula between Fahrenheit and Kelvin scale. So it is very simple. We have been using it in many of the questions previously. So directly we'll go. So on one hand we have the Fahrenheit scale and on the other hand we have the Kelvin scale. So let the temperature in Fahrenheit be TF, T subscript F will denote it by that. So particular reading in Fahrenheit scale minus the lower fixed point in Fahrenheit scale, which is equal to 32 degree Fahrenheit, by the upper fixed point 212 degree Fahrenheit minus 32 degree Fahrenheit, which is the lower fixed point, that is equal to the Kelvin scale. So the particular temperature reading in Kelvin scale will denote it as Tk minus the lower fixed point, which is 273.15 Kelvin, by the upper fixed point, which is 373.15 Kelvin minus 273.15 Kelvin, the lower fixed point. Now according to the question, at this this particular reading, the values of the Fahrenheit temperature reading and the Kelvin temperature reading, it is the same. So let's denote this, the values, the numerical values which are equal that particular temperature reading, let call it Tx. Okay, we'll denote it as Tx. So here it will become Tx minus 32 by 212 minus 32, that is equal to 180, is equal to Tx minus 273.15 by 373.15 minus 273.15, that is equal to 100. So now we'll do cross multiplication. Applies 100 into Tx minus 32 is equal to 180 into Tx minus 273.15. That implies 100 Tx minus 3200 is equal to 180 Tx minus, it's coming around 49167. So be a little bit careful with these calculations, because if you get one of them wrong, then the whole answer will be incorrect. So now it's equal to 180 Tx minus 100 Tx is equal to 49167 minus 3200. So I'm writing it on this side. Okay, that implies, so here what we have done, I have taken this 100 Tx to the RH, this side, and became negative, and this minus 49167, I took it to the other side, so it became plus. So 80 Tx is equal to 45967. That implies Tx is equal to 45967 by 80. So it is coming around 574 574.587 degree. So you can write it as 574.587 degree Fahrenheit or 574.587 degree Kelvin. So either way it will be the same result. So if you want to round it off also, I mean 574.6 degree, you can write that way also, Kelvin or Fahrenheit, that way. So this is the particular temperature reading at which both the Fahrenheit and Kelvin readings, they are the same, numerically they are the same. Okay, so this is that. So here is another question on temperature measurement and temperature scales. So here it is given that the pressure of the gas used in a constant volume gas thermometer at steam point is given by 1.5 into 10 to the power 4 Pascal. What will be the pressure at the triple point of water? And some data is given that the temperature at steam point is 373.15 Kelvin. We have to use this value. So this question is again based on constant volume gas thermometer and on the concept of triple point of water. So if you remember, we discussed an important relationship with respect to the triple point of water, that in a constant volume gas thermometer, the pressure at triple point divided by the temperature at triple point, the ratio of the pressure and temperature at triple point, it's equal to the pressure and temperature values at any other value. Let's say T is any particular temperature and P is the pressure at that temperature at constant volume. So this relationship, it always stays, where P and T are any other pressure and temperature values which obey the relationship, this ideal gas equation, PV is equal to nRT, where volume is constant. This is the important thing. Okay. Now here it is given the pressure of the gas at steam point. Okay, we have to first the temperature of the steam point, that is equal to 373.15 Kelvin, and the pressure of the steam point, that is equal to how much? 1.5 into 10 to the power 4 Pascal. So here this relationship will become PTR by TTR is equal to PSP by TSP, that is at steam point. This is at triple point, this is at steam point. The same relationship it will follow, it will obey the same relationship. The ratio of the pressure and temperature at triple point is equal to the ratio of pressure and temperature at any other particular thermodynamic relationship governed by this equation at constant volume. So here this PSP and TSP is given. The temperature at triple point, we all know the triple point temperature, if you remember, it is equal to 273.16 Kelvin, 0.01 degree Celsius. Okay, So we have to calculate the pressure at triple point. So PTR is equal to PSP by TSP into TTR, which is equal to how much? 1.5 into 10 to the power 4 by 373.15 into 273.16. So it's coming around 1.098 into 10 to the power 4 Pascal, or we can round it off as 1.1 into 10 to the power 4 Pascal. So this will be the pressure at triple point of what? The triple point pressure. Okay, so simply we have used this relationship of the ratio of the triple point pressure and triple point temperature is equal to the ratio of pressure and temperature at any other any other point which is governed by this relationship. PV is equal to nRT, where volume is constant. This. Okay, so this is the